Hello, my name is Caitlin Green, and this is going to be my vlog over the Chapter 9.2 textbook problems. I'm shooting this live from my hometown, so if you hear any dog barking or perhaps a cat jumps on the table, maybe we'll be lucky enough for Cosmo to grace us with his magical statistics presence. But if any of that happens, well, just know there's no place like home. So as you can see here, I have the textbook problems on the screen, but it is a blank copy, so I will be reading all of my answers and how I did the problems from this very marked up sheet of paper. Hopefully it's organized enough that when you look at it, you can make some sense of it. But let's go ahead and begin. So question 5 shows the statistics for 4 separate batches. It says to restore normality from prior research and compare the 4 population variances for equality with alpha of 0.05. And so with these values, I went ahead and also found S squared. Hello. I went ahead and found S squared as well. So we'd have the standard, or I guess the variances, excuse me. And for the variance of batch 1, I found 4.23. For number 2, 29.62. For number 3, 12.3 or 12.13, excuse me. And then for number 4, I found 8.76. The reason why I did that is because we need to find F max, which is the largest variance divided by the smallest variance. And so once I did that, I took 29.62 and divided it by 4.23 to get an F max value of 7.002. which is fairly large, so we're pretty much going to know at this point that it has to be like significantly important, but we should still go ahead and do the hypothesis testing. So our null hypothesis is omega I squared is equal to omega j squared, which is just basically saying that the two values are equal to each other when you're comparing all 4. And then for the alternative, we did, did I say omega? Well, sigma, not omega. Oh, I'm just throwing out Greek letters today. But sigma I squared is not equal to sigma j squared for H1. And then our alpha is 0.05. And like I said before, we found the F max to be 7.002. And once we found the degrees of freedom being 10 and the K value to be 4, we found that the F max critical value was 5.67, and of course 7.002 is larger than 5.67, so our decision is to reject HO and accept H1. And all that means in English is that there's at least one variance in the 4 populations that is not equal to the rest, so one that is significantly larger or smaller. Then on question 6, it says perform a pairwise test for the 4 variances in problem 5. Use alpha at 0.05 at 2 tails. And it says in light of problem 5, are these pairwise tests appropriate? And I can go ahead and answer that for you now because we got a decision to reject HO and to accept H1. That just goes ahead and tells us that we definitely have more work to be done, which is why the pairwise tests are appropriate. But I made a nifty little pairwise box comparison, as you can see here maybe. Like I said, a lot of markups. But basically I just took k minus 1 of the smallest, so since we have 4 values, we'll have 3 going or ascending going on this side and then ascending on this side. However, we'll get 4.23, 8.76, and then 12.13. And then on top, we'll have 8.76, 12.13, and 29.62. Once we find the F max of all of those comparisons, we find that we have 6 meaningful variances, and our top corner with 4.23 and 8.76, we have 2.07 as a meaningful variance. Continuing across that line, we get 2.87, and then of course 7, which we got from our omnibus Fmax. And then if we go to the second row and hop over a square, we get 1.38 as a meaningful variance between 12.13 and 8.76. And then continuing on that row, we get 3.38 as another meaningful variance. And then finally on the bottom row, the only meaningful variance we get is with 29.62 and 12.13, and we get 3.72. However, all of those values, or excuse me, 2.44. The 3.72 is what the Fmax critical that we got for these problems, or the pairwise, excuse me, and we find that only one is significantly larger, which is the 7 being significantly greater than the 3.72. So the only meaningful variance we get was that the variance of group 2 was significantly more than the variance of group 1. No other variances were significant, so that's what we get for our pairwise comparison. Okay, finally, number 9, it says that 9 pairs of littermate rats were tested in a complex task following their rearing in either an enriched environment or impoverished environment, which is E and C. Test the variance of error scores here to determine if the environments had any effect on variability. So basically, if the rats did better in either the enriched environment or the impoverished environment. And we have an alpha of 0.05. And I did the same thing here. We found that there was an N equal to 9, and that I found the variance of E was 20.70, and the variance of C was 22.75. And the reason we need to know that is because of the very long equation of T is equal to the variance of E minus the variance of C, or variance 1 minus variance 2, multiplied by the square root of n minus 2, and then all of that is divided by the square root of 4 multiplied by the variance of E times the variance of C multiplied by 1 minus the variance squared, or 1 minus r squared, and it has 1, 2 underneath it. And to find r, we just use an equation from previous chapters, and I got r to be 0.94. And to fill in the equation, we ended up having 20.7 minus 22.75, and that is multiplied by the square root of 7. Then we divide that all by the square root of 4 times 20.7 times 22.75, multiplied, and there's my Cosmo. Are you going to get on the screen? Don't mess anything up, though. I know. Okay. I'm going to be hearing about that later from him. To getting him off the table so I can do statistics, tisk. But finishing the denominator, we have the square root of 4 times 20.7 multiplied by 22.75, and that is multiplied by 1 minus 9.4 squared. And that ends up giving us a t-value of a negative 0.366. And we find that our t-critical value is 2.365 after using alpha of 0.05, a two-tail comparison, and a degrees of freedom of 7. And so in this problem, we're going to fail to reject HO. And all that means in English is that the variance is between group E and C are not significant. So basically, the two environments did not have a significant, I guess it wasn't very meaningful when rearing the rats in either environment. So this has been my vlog over the Chapter 9.2 textbook problems. Overall, I found this section to be very easy. Let's just fingers crossed that it continues to be easy for me, and I'm about to shoot the Chapter 10 textbook problems vlog. So stay tuned. Thanks.